Hi, my name is Oktay. This video is about the James Webb Space Telescope and its first images that it gave us. The telescope was named after James Edwin Webb. He was the second administrator of NASA in 1961 to 1968. And as early as 1965, James Edwin Webb proposed a large space telescope for NASA. This is a comparison of the James Webb Space Telescope with the Hubble telescope. Left. The James Webb Space Telescope has 18 hexagonal mirror segments. They are made of beryllium, which is plated with gold. The light collecting area is 25.4 square meters. For comparison, Hubble's is just 4.5. This is a picture from the cryogenic mirror testing of the James Webb Space Telescope. One important part of this telescope is the big sun shield, multi-layer sun shield. It is essential for its temperature has to be under minus 223 degrees Celsius, under 50 Kelvin. That is needed for this telescope to operate. The telescope was launched about 1 year ago, on December 25th in 2021, in a Ariane 5 rocket from Kourou, French Guiana. It was deployed to the Lagrange point L2 at 1.5 million kilometers. The Lagrange points are gravitational equilibrium points of Sun and the Earth. This was one of the first pictures from Jupiter. Jupiter is at a distance of 5.2 AU. 1 AU is Earth-Sun distance of about 150 million kilometers. Jupiter is the biggest planet in the solar system. Equatorial diameter is 139,820 kilometers. It is 318 times Earth's mass. And you can see great details of the structure of the Jupiter's cloud system and of the red spot, which is still bigger than Earth, although it's shrinking in size. This is another picture of Jupiter. You can see the auroras at the poles and several of its small moons. For example, this moon Adrastea has just a diameter of 16 kilometers. And just James Webb Space Telescope is still able to see it. That's great. And Jupiter has a high mass, and its rotation period is 10 hours. That's why its magnetic field is very large. It's bigger than the Sun. This is a picture of Neptune. It's at a distance of 30 AU. Its diameter is 49,244 kilometers, has 17 times Earth's mass. And you can see the system of rings and moons. And the advantage of the pictures in infrared and give you more of the structure of this planet. This is a picture of the planet and its biggest moon, Triton, diameter of 2,707 kilometers. This moon is on a spiraling towards Neptune, and will in the far future it will explode and give Neptune a thick ring. This is a picture from the system HIP 65426, which is 385 light years away from the Sun. The system has a super Jupiter with a mass of 6 to 8 Jupiter masses. Its surface temperature is above 1000 degrees Celsius. The James Webb Space Telescope has a near-infrared cam with a coronagraph. And that's a device that can suppress the light of the star, and that makes the planet visible. And that's a great success, being able to capture the light from this planet. This is another picture from James Webb Space Telescope. It's from the planet WASP 96b. Its star WASP 96 is a G-star, a sun-like star, at 1,120 light years distance. The planet 96b is a hot Jupiter with about half the mass of Jupiter, and it's again very hot at about 1000 degrees Celsius surface temperature. And the infrared spectrum shows you peaks from molecule water. And this planet, Jupiter, contains water vapor. This is one of the most famous pictures of the Hubble Space Telescope. It's a deep field from 2017. This was back then a big scientific sensation, because it gave us an idea about the total number of galaxies in the universe. And this is the newest picture from the same field, from the James Webb Space Telescope. And you can see these bright objects in the foreground as stars from our own galaxy. And all the other points, each of them is a galaxy. For example, this one is a nice spiral galaxy. And there are elliptical galaxies. In general, there are three types of galaxies in the universe. There are spiral galaxies like the Milky Way or Andromeda Galaxy. There are elliptical galaxies, and there are irregular galaxies. And within these groups, there are subgroups. For example, there are spiral galaxies with a bar, and some without a bar. This is a picture from the Southern Ring Nebula, NGC 3132. At the left, it's the near-infrared image, and at the right, a mid-infrared image. This is a planetary nebula, 2000 light-years distance. It has a hot central star, which has lost its outer layers. And the layers are now a nebula. And the star has a companion, it's a white dwarf, and both the star and the white dwarf illuminate this nebula, and that's why they have this bright picture. This is a picture from NGC 628. It's called Phantom Galaxy. It's 32 million light-years away. Its diameter is 95,000 light-years. It means it's a bit smaller than the Milky Way, because the Milky Way has a diameter of 100,000 light-years. This galaxy contains 100 billion stars, and you can nicely see the star cluster. This is a picture from Stephan's Quintett, which is actually a quartet, because the galaxy at the left, NGC 7320, is just 14 million light-years away, and all the other four galaxies are 290 million light-years away. So these other four galaxies are right now in a merging process. You can see in the middle this merging process of these first two galaxies. And this is a glimpse of the future of our own galaxy, Milky Way. In 4.5 billion years, the Milky Way galaxy will merge with the Andromeda Galaxy. This is another picture from mid-infrared from the same Stephan's Quintett group of galaxies. You can nicely see the deformation of this structure by the merging process. This is another galaxy, that's Cartwheel Galaxy. It's at a distance of 500 million light-years. Its diameter is 144,300 light-years. It's a result of a galactic collision. And you can see the spiral arms are partially destroyed, but in the future they will regroup, and spiral arms will be restored. This is a picture from the Pillars of Creation. At the left, a picture from the Hubble telescope, and at the right, the much better picture from the James Webb Space Telescope. This is a star formation region at a distance of 6,500 to 7,000 light-years from Earth. And this is what's happening there. That's a you have the formation of new stars together with new planets and moons, new systems. This is another space telescope that's right now in the making. That's the Nancy Grace Roman Space Telescope. It will be able to image directly exoplanets because it will have a coronagraph like the James Webb Space Telescope. It could give us new answers about questions around dark energy. And its launch is planned for 2027. That was the video about the first images of the James Webb Space Telescope. Thank you for watching. Have a nice day. Bye bye.